Hello, namaskar. This is one of my new initiative which I just started, and in this whole recording, I'll try to cover system interview topics. Right. Uh, my plan is to come up with one video every day, but uh, like I said, it is just a new initiative, and if it is not possible, probably I'll shoot one video in a 2 days. But in a matter of 3 months, I'll cover each and every detail of system design. In my video, I'm not going to share any working model because there are plenty of videos available on YouTube. You can go and watch those system design aspect from the working model, right? So here, my content would be more for those who understand uh, aspect of system design, and they just want to uh, understand different topics in a very faster manner, or they can just play on a YouTube and then do other work, right? And they'll get a overview of different system design topics. So without any further delay, let's get started. So today's topic is URL shortening. So we create a lot of URL uh, endpoints, and those endpoints are really big. Okay, it's very difficult to comprehend. It's very difficult to remember, right? Again, it's very difficult to keep track of those URLs. So what happens is we call another service which actually shorten the URL, and which is more easy to write, or let's say we are in a situation where we have to write the endpoint each alphabet and then ping. In that scenario, the big URL could be difficult because it is very difficult to write each and every letter perfectly, and then it is time consuming, is not it? So that is where URL shortening comes into picture, and obviously we are going to understand how many uh, requests are going to come on our service, and and which geography is generating these URLs, right? And then how much traffic is landing. Let's say uh, probably one request per second, which means that 60 requests per minute and 3600 requests per hour. And do you do the calculation, right? So you'll get that, okay, how many requests we are getting in a day, right? And based on that, we can provision resources, whether we are going to provision on a AWS or Azure or GCP. That is up to us. Like we can design, right? So, and where we are going to deploy. Look, in current scenario, Kubernetes would be the best place where you can deploy your services. In fact, a lot of database, which was not the case earlier, even being deployed on the Kubernetes clusters. So why Kubernetes, right? Why not other? Why not just simple compute? Why not just Docker, right? So because of the obvious reason, the Kubernetes brings a lot of capabilities and save a lot of infrastructure, right? Every time we don't need a full-fledged virtual machine, we can leverage that machine for multiple applications. And how we can do that? Earlier, hypervisor was the setup, but hypervisor is not that easy or not that seamless, and again, it cannot create as many as compute which can be done by Kubernetes. like part, right? So if you really want to deploy your service on a minimum infrastructure which is highly available and gives you very low latency, the Kubernetes is your choice, uh, your option, right? So we will come up with a service which is going to shorten the URL. Uh, Obviously, right after it lands on our service, what it does is it is going to shorten that the the URL and keep that data mapping in a database. It is very important to understand what database we should use because uh, otherwise we are going to uh, wrong database can be very costly, or it can be very uh, performance centric design, right? So how we can avoid that? We must choose right database, and that derives what business we are doing, right? What is expected from our service. Here, acid is something which is not very important because here is not like banking transaction and then uh, only for that basically transactions where we have URL and then we have a sort URL. So obviously it is very important that one URL which we have created and it is larger, there must be a sort URL map to this. And if it is not happening, there is a problem, right? Because one URL which was generated and it doesn't have a sort URL means there is some problem, right? So for URL mapping, we can have a MySQL or Oracle or Postgres or any relational database, right? For all other activities like converting the URL into letters and then later into the base 65, right? That is really not needed relational database. Again, relational database is a little costly, so we must consider all that aspect while designing the system, right? So cost, resource utilization, and whether it is structured or non-structured data, like data with whom we are dealing, right? So we need to understand, and then what is the kind of business we are running, right? So these all conversation must go into discussion and then only come up with the design, right? So whenever we have a situation where we need to maintain in and out, and there should not be a single transaction where in is there but out is not there, right? So in such scenario we need to maintain atomicity, consistency, isolation, and durability. So in such scenario we must use SQL or relational database, and where we have a just data which is, let's say, URL is how many URL is basically processed today, what are those geography of those endpoints, and like other analytics related to, okay, the number of URL which are more frequently converted or sorted, or the kind of endpoint which are being generated, all that analytics we can put into the columnar based database like Cassandra, like MongoDB, right? And that will help basically to uh, keep our data in a very efficient manner, and it will not cost us a lot because SQL is really costly database, right? So Cassandra is something we can utilize here, and look, our requirement was just to shorten the URL, and then when somebody is clicking it, we must enlarge that URL. So that we can do it through the SQL, right? So we can database mapping, and then again, we need to understand if our use is in a trillion. So the URL shortening and using the different characters, it we should not go out of those characters, right? So we must define probably one database where we have maintained all that. Okay, this is the range, uh, all that endpoint or request which is coming on particular. Let's say we have multi-agent deployment where our URL shortening and URL enlarging services are deployed, and it is deployed on multiple zones. So obviously, because we are talking about trillions of transaction in a day, right? Or trillions of transaction in a month, right? So uh, so here we need to maintain how we are going to generate the certain URL, because one endpoint and because of multiple services, it generated same certain URL for the multiple endpoint, which will be like single point of failure. Like we have one database which is generating all the URLs, and then uh, after that there is another database which is generating another set of URL. So we might land into situation where we have one endpoint, two endpoint, three endpoint, but certain URL for all three is one, and that will uh, break our system. So we have to consider how we are going to generate the uh, endpoint, certain endpoint. And let's say if we have one place, one service which is generating all these certain URLs, it helps us to keep unique certain URL, but it will be too much overload on that application. And the thumb rule of system design is we must not create a single point of failure, right? So here what we can do is we can divide that server into multiple server, and then the problem happen is uh, multiple endpoint has the same certain URL. So how we can achieve that? We can, like I said, that we can introduce range. Okay, in first service, the URLs are going to use these characters in this format, and the second service URLs are going to be using these characters within this range, like that. Then what happens? We need to maintain that range. That is extra overhead. Why we need that? And then again, we can have a multiple deployment for the range. Again, in that scenario also, like we have to maintain that on this server this is range, on other server this is range, and on third server this is range, and then like that, right? So so that needs extra person to have a look continuously. So instead of that, we can have one system which is a tokenizer, right? So tokenizer is service which ensures that all the characters which are being used are going to generate a unique URL for every shortening services, right? So that can help us to achieve this, and we can have multiple such services and ensure that each services are in sync and nobody is generating same shorten URL for two different endpoints, right? So we ensure that the consistency is in place and uniqueness in the place. With this, uh, we have come up with a service or basically a product which is going to shorten the URL and enlarge it while assessing it, right? So the flow would be like user sending request to shorten the URL, right? it will land on our load balancer, and load balancer will distribute the load according to the algorithm or distribution algorithm what we have set. It will land on our application. Application will take that endpoint, use that range, shorten that URL, ensures that it is unique URL, and then sends back to the user. When user clicks on it, again it comes on our load balancer, go to that enlarging service, and that service will see the mapping of this URL in database and pulls that large endpoint values and gives back to the user. This is a complete flow, right? Now, are we going to achieve only these things? We have so many information, and this is a very simple service, right? Why not we can leverage that data which is being generated through the multiple sources, like you see Amazon, uh, how they are handling, right? So they don't do just one thing. So here we can come up with a analytics service, right? Analytics service is going to be very light because it doesn't need any payment thing, it doesn't need any uh, calculation. It's just like, okay, we are just pushing all that data, all the log into Kafka will use the different search algorithm, or this is different data manipulation algorithm, and create one dashboard, and that can be leveraged for our use case, maybe in today, maybe tomorrow. But if we are adding new service, it might reduce the latency, because it might increase the latency, right? So then our service is going to be in no use, because one thing which is super important for our requirement is we need to have this shortening URL service, which gives or returns back a certain URL with a very low latency, and it is amazingly highly available, right? It must be in that kind of setup. So if we add new analytics service, it is going to eat up some of latency, and then latency will increase, and that will be very slow. So what we can do, instead of having an analytics service in our application, we can have this service as a parallel service, and it will just, instead of URL sending, it will just fetch that information and process it separately in parallel, and then gives back you a dashboard. I think that is the perfect approach. So couple of things which we need to ensure while designing such kind of system, right? One is we must ensure that we are resource optimized. The cost for the resources are going to be minimal, and it ensures that the system is highly available, and it offers low latency when it comes into business. And now, when we started this system design discussion, we spoke that one transaction per second, right? But when it is really heavy traffic, which means that transactions happening in trillions in a minute or in a second, that time we need to just auto scale this same setup to that extent, and then it will go flawlessly, right? So obviously the deployment and the security policies and the access control, that obviously we need to discuss that too, right? So the kind of access, who would be assessing what, and who can change what, all that, right? We can have a role based access control. We can leverage Azure or LDAP from the AWS, and create a one LDAP, and then in LDAP pull out all those access policies what is needed, and we can create couple of AD group, right? So AD group will help individuals to get a right access, right? So that is the kind of um, process we can use to design this application. I guess this is pretty much what we need to do for this service, and hopefully this was somewhat insightful data. And if you have any feedback or if you have any question, feel free to share that, and really that will help me to be a better. All right, so until next topic, take care, thank you. Goodbye.